this quotient rule then, used to differentiate when we've got one function divided by another. And again, before you automatically just use the quotient rule, if the two functions could be tidied up, then tidy up algebraically. You know, 3x squared divided by 2x, you tidy that up. But if I've got two perfectly distinct functions, 3x squared divided by a completely separate function, sine 2x, then I'd have to use the quotient rule. One divided by the other. This time, I call the top function u and the bottom function v. And it's very important that you do it that way round. So v always represents the bottom function. In the product rule, it doesn't matter which one you call u and which one you call v, because they're both multiplied together. So the order doesn't matter. It does matter when you do a division. So v is the bottom function. And then we apply this rule, which looks quite complicated. Here it is, written down. dy by dx equals v, which is the bottom function, multiplied by the differential of the top, minus the top function multiplied by the differential of the bottom, all over the bottom function squared. So you might decide that you want to actually remember it like that, so there it is written. But we have to apply this thing. So let's try it with this example, the one above. Now, as it's a bit of an awkward function to use, this quotient rule, I would recommend that you do it step by step. It leads to less errors. So in other words, you're going to write down what u is, as you do for the product rule, 3x squared, and differentiate it. Differential of 3x squared is 6x. And then you're going to write down what v is, sine 2x. The beauty of these rules is that once you've done one or two, the method is always the same. This is exactly what you do each time. What's v? Sine 2x. What's the differential of v? 2 times the cosine of 2x. Sometimes they're not, as I've said before, quite such straightforward things to differentiate, but in this case it is. So now all I've got to do is put these values into that quotient rule. So we write down the quotient rule, dy by dx equals v du dx minus u dv dx all over v squared, this horrible thing, and then put the values in. What is v? It's sine 2x. So literally just write in what the values are. What is du by dx? 6x minus u, which is 3x squared, times dv by dx, which is 2 cos 2x, all over whatever the bottom function is, which is sine 2x squared. So just put a bracket around it and square it. And that is the answer. Now we try and tidy up. And actually in the quotient rule, not particularly in this example, but in some examples you'll see, it's very worth trying to tidy up because the answer suddenly looks a lot more straightforward by trying to tidy it up. So now I would ask you to try and tidy these things up. So a few little tips to think about when you do this. So looking at the top, a few tips for when you do try and tidy these things up. Put numbers first. So looking at this first term, I'm going to put the 6x first, followed by the trigonometric function. Here, I can combine the 3 and the 2 to make 6. So 6x squared times cos. So we get 6x sine 2x minus 6x squared cos 2x, all over the bottom bit. There's a convention that we talked about before. For sine 2x all squared, we would write sine 2x, and then if I put the square here, that means the sine of 2x all squared. So that convention we use to mean sine 2x is squared. Now we can factorize. We can take, again, as we did before in the product rule, the 6x outside a bracket, leaving sine 2x minus x times cos 2x all over sine 2x all squared. And that would be how we'd leave the answer.